So we're going to be finding the domain and range of this exponential function. So a couple things that we need to determine is the asymptote and if it's a growth or decay. And all the asymptote is basically going to be your k value, whatever is being added to the function. Since there's nothing being added to this function, think of it like you're going plus 0, and that 0 is your asymptote. So we have y is equal to 0. That means that on our graph, the x-axis is our asymptote. Then if you look at this number right here, this is our b. Since our b is greater than 1, that means it's a growth. So we know how our graph is going to look something like that. The next thing we're going to do is do a table. And pretty easy. The numbers that I suggest to do are -1, 0, 1, and these always work. It's just so we could sketch the graph, and those are pretty simple numbers to pick because you're picking a number or choosing a number on the left side of your graph, one on the axis, and then one on the right side. So those kind of give you a nice sketch. So once we do that, all we are doing is wherever we see an x value in our function, we substitute it in. So we have 2 to the -1 power, which is just a half, because you're going to need to know your properties of exponents here. 2 to the 0 power is 1, and 2 to the 1 power is 2. So now we have values that we could actually plot, which we have ordered pairs. So our first order pair is -1 and 1/2. So -1 and 1/2 would be here, approximately, 0 and 1, and 1 and 2. So now just sketch your graph, and that would be our exponential function of growth. Our domain for any of these functions, if you notice, this function keeps going to the left, so it gets all the negative numbers that exist, and this will be going wider and wider and wider as we go along, so it's going to get all these numbers on the right side. So for exponential functions, especially these that are given, your domain will always be an x's element of the real numbers, so every number works. Your range, on the other hand, you're going to have y as the element of the reals, but if you notice such that you have no function down here, it's always going to be from whatever your asymptote is above that, greater than that. So if my asymptote was 0, that means it's all the numbers greater than that 0. So we have y is greater than 0 as our range. So for this function is the same thing, but if you notice, in this case, our b is between 0 and 1. So that means anything that is between 0 and 1, aka a fraction or a decimal that is between 0 and 1, is going to be a decay. So that means this graph is going to kind of look like this. So it's going to start high and then slowly go down. Again, our asymptote is going to be 0 because there's nothing being added. Equals 0. So again, it's just the x-axis. We're going to create our table, and we're going to use, again, those three values, -1, 0, 1. And we're going to substitute it in there. So we're going to have 1/3 to the -1 power, which just gives you 3. 1/3 to the 0 power is just 1. And 1/3 to the 1 power is just 1/3. So when we graph that, our order pairs are going to be -1 and 3. 1, 2, 3. 0 and 1, and 1 and 1/3, somewhere around there. And that means our graph is going to look something like that. Our domain, again, is just going to be x's element of the reals, and our range is going to be y's element of the reals, such that y has to be greater than 0, because that's where we have our graph. For this function, again, we have no vertical shift up or down. So that means our asymptote again, is y equals 0. It's not always going to be y equals 0. It's just that these examples that I'm giving you right now, they are y equals 0. Can't really see that. Let me highlight that. So that's our asymptote right there. So again, we're going to just do our t-table. But now we have an actual a value of 2. So we're going to get our x and y. We're going to start our t-table, and then we're going to use our numbers -1, 0, 1. And again, we're just going to substitute into our equation and simplify it. So we have to the -1, which that's going to be 2/5. 2 to the 5 to the 0 power, that's just going to be 2. 2 times 5 to the 1 power, that's going to be 10. So if I graph this, we're going to have a -1 2/5. That's around there. We're estimating 0, it's at 2. And at 1, it's at 10. So all the way there. So we're going to have a graph, or sketch a graph that looks something like that. And again, the domain of all exponential functions are x's and other reals, which is all x's that exist. Your range is y's and other reals, such that it's all the y's that are greater than your asymptote. So our asymptote is 0, so greater than 0. And if you notice on this one, we have shifts. So we have a h and a k now. And this is still our a, and this is still our b. So first thing, we're going to identify our asymptote. So our asymptote in this case will be y is equal to -2. So at -2, right here, we have an asymptote. So our answer is going to be above that asymptote. So we're going to have, we're going to have two t-tables. One with just our 4 to the 1/2 part, and then one with our h and k shifts. So we're going to use a -1, 0, 1, just like we did on the previous examples. And when we do that, we're going to have 4 times to the 1/2 to the -1. That's going to be 1/2 to the -1 power is 2. 2 times that is going to be 8. 4 to the 1/2 to the 0 power, that's 1/2 to the 0 is 1. 1 times 4 is 4. And then to the 1 power, that's going to be 1/2 times 4, which is just 2. And then our next t-table, we're going to switch it. And now we're going to do the opposite of my h and same k. So now we're going to add 3 to all our x values, and we're going to subtract 2 from all of our y values. And the reason we're doing that is because this is a shift for our x values. So these numbers are going to be shifted 3 units this way to the right. This is our y shift. That's our up and down shift. That means all of these values were shifted down 2 units. So that's why we're subtracting 2 from there and adding 3 to these. So our new values that we're going to graph with the horizontal and vertical shifts are going to be, so 3 minus 1 is going to give us 2. 3 plus 0 is 3. 3 plus 1 is 4. So those are our shifts now. And on our next one, -2 plus 8, that is 6. And 4 minus 2 is 2. And 2 minus 2 is 0. So those are our new points with the vertical and horizontal shift. So that means that 2, 6. So 2, 6 would be here. 3, 2. So 3, 2. And 4, 0. So we're going to have an exponential function that looks like that. And for our domain, again, it's just going to be x's and other reals. For our range, it's y's and other reals, such that y has to be greater than our asymptote, which is -2. Which, right here, this is our asymptote, -2. All our answers were greater than that, nothing below it. Okay, this is going to be our last problem. Same thing. We're going to start with the asymptote, identify that. And our asymptote, again, is our k, which is going to be y is equal to -1. This is our H. This is our A. This is our B. Okay, since our B is greater than a 1, we know it's going to be a growth. And our A is just basically going to give it a stretch. So, or compressed, depends on what the number is. In this case, this is 4. So we're going to do our T table. And we're going to use the same numbers we used, negative 1, 0, 1. Those always work. And we're going to substitute. We're going to use just this part. We're not going to use our H or K yet. That's going to be for our second T table that we're going to do. Those will be our shifts. Okay, so first things first, we have 4 times 2 to the negative 1 power. That's going to be 1/2 times 4, which is just 2. 4 times 2 to the 0 power, that's going to be 1 times 4, which is 4. 4 times 2 to the 1 power, that's going to be 8. And now we're going to do our actual shifts. Remember, so opposite of our H, same K. So that means we're going to add 3 to our X values, and we're going to subtract 1 to our Y values. So 3 minus 1 is 2. 3 plus 0 is 3. 3 plus 1 is 4. 2 minus 1 is 1. 4 minus 1 is 3. 8 minus 1 is 7. And those are the values that we're going to graph. So we're going to, I forgot to graph my asymptote. So if I graph my asymptote, and that's going to be a negative 1, so that's going to be this line right here. And we're going to graph our points. So 2, 1, 3, 3. So 1, 2, 3. 3, 3, and 4, 7. 5, 6, 7. So we're going to have something that looks like this. Oops. And for our domain, again, is X is the limit of the reals. Our range would be Y is the limit of the reals, such that all my Y's are going to be greater than my asymptote, which is negative 1.